Today we are going to be doing function operations. So we're going to be adding two functions together, or subtracting, or multiplying, or dividing, or composing. And then that's the easy part. Then you have to figure out what the domain and the range is. So if I had f of x is 6x minus 3, and g of x is, let's say, whatever. I'll make it easy to start with. X plus 3. The assignment says find f plus g, f minus g, f times g, and f divided by g. So f plus g of x. This is the name of a new function, and that function is found by simply taking f of x and adding it to g of x. So that would be 6x minus 3 plus x plus 3 gives me 7x. What is the domain of 7x? And when we talk about domain, we have to think about numbers that we are not allowed to plug in. Are there any numbers we're not allowed to plug into 7x? No. There are only two ways to ruin a domain. What are they? Divide by 0 and square root negatives. Do I need to worry about either of those in this case? Nope, so the domain is all real numbers. Does it want me to find the range? Oh, good. Doesn't. So the domain of this function is all real numbers. Okay. Then it wants you to find f minus g of x, which is simply f of x minus g of x. So I take 6x minus 3 and I subtract x plus 3. What will that give me? 5x minus 6. What is the domain of that function? All real numbers. We never have to worry about dividing by 0. And we also don't need to worry about square rooting negatives. Okay. What about f times g of x? And that is done by taking f of x and multiplying it by g of x. So I take 6x minus 3 and I multiply it by x plus 3, and I get 6x squared. That gives me 18 minus 3 is plus 15x minus 9. What's the domain of that function? All real numbers. Okay, that's pretty simple. And then we have to do f over g of x, which is simply f of x over g of x. So that would be 6x minus 3 over x plus 3. What is the domain of that function? Everything except negative 3. So the domain would be from negative infinity to negative 3, union with 3 to infinity. Does that make sense? Oh, sorry, negative 3. So this is a problem when x equals negative 3. You plug in negative 3 and you divide by 0, which is either infinity or negative infinity, and that doesn't work. So we're not allowed to plug in negative 3. Right. So you have to find the addition, the subtraction, the multiplication, and the division, and state the domain. Okay. Look at number 2 is really easy. Let's do number 4. Okay. F plus g of x is going to be 3x plus 2 plus x squared minus 25. That gives me x squared plus 3x minus 23. Look at problem number 4. F is 3x plus 2, and g is x squared minus 25. Hey, psst, psst. Learn this, then we can help you with that. Thanks for trying to help. So, does this have any domain restrictions? No, we never divide by 0, and we never square root a negative. Okay? And then we could do the subtraction, which is essentially this. Now I get negative x squared and plus 25, which gives me plus 27. Does that have any domain restrictions? No, we never divide by 0, and we never square root a negative. All right, if I multiply them, I get 3x plus 2 times x squared minus 25, which is 3x to the third plus 2x squared minus 75x minus 50. Does that have any domain restrictions? No, we never square root a negative, we never divide by 0. But when I do the division, I get 3x plus 2 over x squared minus 25. Does that have any domain restrictions? Yes. If I look at this, x squared minus 25 equals 0, I factor it, and I get x plus 5 and x minus 5. I write equals 0 on both of them. X is not allowed to be 5 or negative 5. Because if it is, the denominator equals 0, and we get undefined. So the domain would be negative infinity to negative 5, union with negative 5 to 5, union with 5 to infinity. Does that make sense? Both of you have had your phone out, and now I have to write both of you up. No, 3 minutes ago. I know. I was going to wait so it wasn't on the video, but now it is. I think you should probably go back to your original seat, because I think you're going to get yourself into trouble back there. Was it your phone? And you're both using your phone. Gosh. Oh, you guys. Okay. Let's do number 8. So number 8, our f function is the square root of x minus 1. And 2x squared is g of x. So the addition is simply going to be the square root of x minus 1 plus 2x squared. We can't simplify that. Are there any domain restrictions? Yes. We know that the stuff inside the square root has to be 0 or bigger. So I write x minus 1 has to be bigger than or equal to 0, and I add 1, and I get x is greater than or equal to 0. So the domain would be from 0 to infinity. Okay? Now the subtraction is going to be very similar to that. So if I change this to a minus, it still doesn't simplify, and the domain restriction is going to be the same. From 0, or sorry, not from 0, from 1 to infinity. Okay, I think I wrote 0, didn't I? I meant this. Sorry. From 1 to infinity. Okay? When I multiply those together, that's just 2x squared times the square root of x minus 1. Does that have any domain restrictions? Yes. This has to be greater than or equal to 0. So x minus 1 is greater than or equal to 0. Add 1. X is greater than or equal to 1, which is 1 to infinity. Well, the next one won't be. The division is the square root of x minus 1 over 2x. What are the domain restrictions? Well, this one has to be greater than or equal to 0, and this one is not allowed to be 0. So up here, I get x is greater than or equal to 0, and down here I get x is not allowed to be 0. So, oh my goodness, I did it again. Messed up the magic trick, messed up the math. I quit. There we go. Oh, that's a 0. So, does this get in the way of that? No, it's not even part of it. Okay, so the answer is just that. But what if x was not allowed to be 6? What would we need to do? You'd have to go from 1 to 6, union with 6 to infinity. Does that make sense? Okay. What if I plug this one in backwards in the... Oh, wait. No, that's not what I meant. All right, so that first set should be pretty simple. Number 9 might give you some trouble, but you guys are smart. You'll figure it out. Okay. Now, composing functions. Okay, let me give you a really simple definition of composing functions. Okay. Oh, how am I going to do this that makes sense to you guys? How many of you were not born in Price? Couple? Okay, good. So, so I have a function where Tiana was born in what city? So Las Vegas. And okay, where were you born? Belle was born in Payson. And Aurora, where were you born? Awesome. Aurora was born in Price. Okay, this is a function. Kyson, where were you born? So Kyson was also born in Price. Is that still a function? Yeah. But nobody can be born in 2 different cities. Right? You're either born in one city or born in another. So it's a function because every x is connected to one y. And it's okay if y's are connected to more than one x. That totally makes sense. Lots of people can be born in the same city, but no 2 people can be born, or no 1 person can be born in 2 cities. Well, I'm going to create another function that says Las Vegas is in Clark County, Nevada, okay, and Payson is in Utah County, and Price is in Carbon County. Okay, so this first function I will call f, and the second function I will call g. Now, I can actually link the g function to the f function because the range of the original function is identical to the domain of the g function. So what I'm going to do is this. I'm going to put function g right here and then say Clark County, Nevada, Utah County, Utah, and Carbon County, Utah. And I get this. Okay? So I can do what is called composition of function. I can kind of daisy chain the functions together. And what that allows me to do is skip the middleman and say Tiana was born in Clark County, Nevada. Bell was born in Utah County, Utah, and both Aurora and Kyson were born in Carbon County, Utah. Okay? So we take one function and another function, and we kind of blend them together, and we skip the middleman. This function is called, hold on. I don't want to write this backwards. So this function is called G composed with F. And that's just a little, it's not a dot like multiplication, and that's kind of, it's a little circle, and I drew it a little too big. So G of F of X. And the definition of G of X is G with F of X inside it. Okay, and let me show you what this means. These are my X's. Okay, and then these are called my Y's, but they're also known as F of X's. And then this is my G of X. So to figure out where a person, what county a person was born in, I take the person who is an X, and I plug them into the F function, and I get my F of X, which tells me the city they were born in. Then I take those cities, which are my F of X's, and I plug them into my G of X equation, and I get the counties. So if you look here, we start on the inside with the X. We plug X into F and figure out the city. Then we plug the city into G to figure out the county. And G of X actually allows us to skip the middleman. Okay, let me show you what that means. So, look at number 12. F of X is X squared minus 1, and G of X is 2 minus X. So I want to find F composed with G. And what that is saying is take G of X and stick it inside F of X. So I don't know if you understand what that means, but this is what it means. I'm going to take this and put it in there. Okay? So this goes inside that, or this goes inside that. Okay? So G of F, I'm going to take this 2 minus X, and I'm going to put it inside the X. How do you do that? You put it where the X is. So I'm going to stick this in here. So F of X is equal to X squared minus 1. But instead of X, I'm going to write 2 minus X. So I get 2 minus X. Then I can multiply that out, and I get X squared minus 4X plus 4 minus 1, which turns into plus 3. Okay, did you understand how that works? You put the second one inside the first one. Now, what does this equation do? Well, the first equation, the G of X, turned people into birth cities. And then the next function takes birth cities and turns them into counties. And this function, x squared minus 4x plus 3, skips the middleman. Right. So let's find out what is what is G of, let's say, 0? What happens when I plug 0 into G? 2 minus 0 is 2. Okay? Now I'm going to put that 2 into F of X. I put 2 in here. 2 squared is 4. 4 minus 1 is 3. Okay? Now, what happens when I plug 2 in here? 2 squared is 4. Minus 8 is negative 4. Oh, shoot, I messed up. What did I do wrong? No, I'm plugging in 0. Sorry. I'm plugging in 0. 0 squared minus 0 plus 3. Okay? Now, this is kind of complicated, but what it's saying is f of g of 0 is equal to 3, which is equal to f of g of 0. So the slow way to do this is to plug 0 into g, turn people into birth cities, and then take the cities and plug them into f, which is plugging cities into counties. Or this skips the middleman, and you plug in 0 and you get 3, which is the same on both sides. Okay? Now that seems super complicated, and it's a little bit complicated, but it shouldn't be too bad. So let's try it the other way. Let's do g of f of x, which means I take this and I stick it in there. So I get 2 minus, and where the x is, I'm going to put x squared minus 1, which is negative x squared plus 3. Okay, does that make sense? All right, what time do we get out of here? 45 after. Okay, we've got plenty of time. Good. Oh. Okay, what about the domain? The domain is really complicated. Well, it's confusing. It's not complicated. It's hard to wrap your head around it. Okay, so we have 3 different functions here. We can find the domain of f, the domain of g, and the domain of g of f. There are 3 different domains to look at, and I'm not going to go into why this is the case, but the domain of g of f. So this domain ignores the domain of g. And the domain of g of f is simply the domain of f intersected with the domain of g of f. And it's really hard to explain why that's the case. And in years past, I've tried to do it, and it just doesn't work. So this domain is that domain compared to this domain. You don't need the domain of g, which is weird, but that's just how it works. Now, in this case, do we have any domain restrictions there? Oh, yeah, right there. No. Do I have any domain restrictions here? No, so the domain is all real numbers. Okay, let me find one that does have domain restrictions. 14. So f of x equals 2 over x minus 3 and 2 plus x. Okay, pay close attention. If you don't understand, I'll try to explain it from a different angle. Oh, that's g of x. Let's find f of g of x. Which one do I plug into which in this case? I plug the g function into the f function, because this is essentially f of g of x, and that kind of makes sense. G of x is sitting inside the f of x. So I'm going to take this function and plug it in here. So I get 2 over, the x is now 2 plus x minus 3, which gives me 2 over x minus 1. Okay, does anybody not understand that? We're good? Okay. Now the domain. The domain is tricky. First, we have to look at the domain of G. Does G have any domain restrictions? No. So the domain of G is all real numbers. Okay. Now we look at the domain of this. Does this have any domain restrictions? Yes. X is not allowed to be 1. Does anybody not understand why X is not allowed to be 1? We're good? Yeah? Okay. So this one has a domain which is all real numbers, and this one has a domain where X is not allowed to be 1. So what we do is we combine those two domains into a single domain, and we end up with X is not allowed to be 1. So the domain is from negative infinity to 1, union with 1 to infinity. Now, notice, I skipped this domain. I didn't even look at it. And while there are domain restrictions on there, it turns out that when you do the composition of functions, the domain of f is not important. And I'm not going to get into why. Okay. So let's do it the other way. We're going to do g of f of x. That means we plug the f function into the g function. Okay? So I stick this right there. 2 plus 2 over x minus 3. Okay? So does this function have any domain restrictions? Yes. X is not allowed to be 3. Okay? Does this function have any domain restrictions? X is not allowed to be 3. So my domain is X is not allowed to be 3. Negative infinity to 3 and 3 to infinity. Okay? So we look at the domain of this and the domain of that. And I skipped the domain of G. You don't even need to look at it. Okay? How many of you are lost? A couple? Okay. Let's try another one. Let's do 18. So f of x is the square root of x minus 1, and g of x is x squared plus 2. Okay. F composed with g. What does that tell me to do? Plug g into f. So I take the g function and I stick it right there. So I get the square root of, it used to be x, now it's x squared plus 2 minus 1, which is x squared plus 1 with the square root over it. Okay, that's the easy part. Does anybody not understand how to do that? Everybody good there? Yeah? Okay, now, oh, go ahead. Two minus 1 is 1. I just simplified. Okay, now for the tricky part, the domain. I'm going to look at the domain of G and compare that to the domain of the whole composition. So, does the original G function have any domain restrictions? No. So we don't need to worry about that. Does the composed function have any domain restrictions? Well, I know that this is not allowed to be negative. So x squared plus 1 has to be greater than or equal to 0. Does that ever happen? Does it ever not happen? What sort of number is x squared? If I take a number and square it, what do I get? A positive number. When I take a positive number and add it to 1, I always get a positive. Right? A positive plus a positive is a positive. So is there any way for x squared plus 1 to be less than 0? Right? That graph looks like this. Does that graph ever dip below the x-axis? No. So are there any numbers I'm not allowed to plug in? No. You can plug them all in. So the domain would be all real numbers. Okay? Let's do it the other way. G of f of x. Or, sorry, it's written this way. Okay? So I'm going to take this and I'm going to plug it in there. So I get what used to be x squared plus 2 is now the square root of x minus 1 squared plus 2. How does that simplify? Squared and the square root cancel, and I get x minus 1 plus 2, which is x plus 1. Where do I look for the domain? Well, I look for the domain of f. Does f have any restrictions? Yes. X must be, so x minus 1 is greater than or equal to 0. Add the 1. X is greater than or equal to, God, I did it again. Sorry, guys. X is greater than or equal to 1. Okay? Now, does this have any domain restrictions? No. So this is the domain from 1 to infinity. Okay, now this domain thing is a little bit tricky. You guys are okay with composition, right? So what if I had f of x and the domain, I really need to quit teaching today. So the domain of this function is x is not allowed to be 4. And then g of x, the domain of this function is from -2 to infinity. And if I did f of g of x, and I'm not writing the equations out, I'm just showing you the domains. And this function has a domain from -infinity to 2. What is the domain of this? What do I look at? Well, I have to look at the domain of g, which is this one, and compare that to the domain of f of g. So when I combine this domain and this domain, what do I get? What numbers fit both domains? Everything from -2 up until +2. Does that make sense? So whenever you do a composition, you compare this domain with the entire domain, and you see which numbers fit both. Okay? If I were to do g of f, and that domain is, let's say, from 1 to infinity, what is the domain of g of f? Well, I need to compare this domain and this domain. What do we get? Grab it. So from -1 to 4 and 4 to infinity. Well, it's this. It's all of this except for that number. It's 1. Yeah. Yeah, this is a 1. So this is a 1. So this composition thing is going to be a little weird to you, but there will probably be one of these questions on the final. So if I had A composed with, A composed with B of X, and I wanted the domain, I compare B of X domain to A composed with B of X. And I can ignore the A domain altogether. And again, it's kind of weird, but that's just how it works. Okay? All right, get to work. There it is.